Okay, this is part two of clearing the fractions. Now, here we are with this example of 5x divided by x plus 4 plus 20 divided by x equals 80 divided by x squared plus 4x. Now, what's going to happen in these problems in this video are you need to do some factoring. Specifically in the denominator. I'm talking about the denominators here. It's going to be very useful to factor wherever we can the denominators. Notice that x squared plus 4x is subject to the principal greatest common factor. So having done that in the second line, we can analyze and say, okay, how are the denominators shaking out? We have x plus 4, we have x, and then we have x times x plus 4. What is the common multiple of all three of those? Well, x times x plus 4 will do the job. Well, if that's okay, then we can multiply both sides of the equation by x times quantity x plus 4, which I have done in green right here, and distribute. So again, the process is not different in kind from what we did before. It's just a little bit more complicated looking. But observe that after distributing, we can do cancellation. And I indicated the cancellation by striking through the expressions that can be canceled out in red pen. And if we do our job right, we'll get to a point here in this line where we don't have fractions anymore. We will likely have some distribution issues to deal with, which we do here on this right term, the 20 times x plus 4. So distribute, and basically, well, adding like terms, yes. Also recognizing that we're involved with a quadratic situation here, which means it will be ideal to set all the terms over on one side equaling 0 on the other side, which I've done here. And we don't need anything too complicated with regards to the quadratic because we can use the principle of greatest common factor. We don't have to use, quadratic formula, completing the square, all that stuff. I mean, yeah, one could do that, but it's completely unnecessary. GCF does the job. So here we are. We'll have two equations coming out that we need to solve. And after checking them, well, 0 for x, I put it into the original equation. And, you might be seeing this right off the bat. There's something off the rails here. 20 over 0 is what would be necessitated if I put in 0 for x. And that's off. There ain't no 20 over 0. Okay, so I indicated that down the bottom here by, hey, 20 over 0 is not a number. So the so-called solution x equals 0 is wrong. It's not wrong algebraically. There's no error here, I don't think. It's just that this is going to happen sometimes. And that's okay. Well, then how about x equals negative 4? Well, let's see. If you'd come back to the original equation and say, hey, negative 4 plus 4, that's a problem right there. It is. But I write it out down here in red so that you can see that, indeed, negative 4 plus 4 is giving us a 0 denominator, and that ends the story. The solution, the so-called solution x equals negative 4, is just not going to work. Therefore, there isn't any solution. There is no x value, as it turns out, and this is not obvious. There's no reason why it should be obvious at all, that there's no number that, when put in for x, would give you the same number on the left side as on the right side. That's simply it. Okay, well, let's look at a second example. All right, here we go. Okay, number 2 of this sort. Okay. So in this problem, we have 6 divided by x plus 3 plus 2 divided by x equaling 5x minus 3 divided by x squared minus 9. The reason I chose this as the second example is, yes, we have factoring to do over here of the x squared minus 9. That involves what's called the difference of squares factoring technique. And I think I alluded to that in the last class we met before the break. Difference of squares. In English, you could put it like a squared minus b squared equals a plus b times a minus b. It's a pretty important factoring principle. And we need that here, and it does the job very nicely so that we can look at the denominators and pick out, okay, what are we talking about? We're talking about x plus 3, we're talking about x, and we're talking about the product of x plus 3 times x minus 3. What is the common multiple of all three of those? Just basically multiply them together, x times x plus 3 times x minus 3. Multiply both sides of the equation by the common multiple. And do the cancellation that comes about, which I've indicated with red strike through marks. And then we have a lot of distribution that goes on here. Just keep at it. Add like terms. At some point, you may start to recognize that you have a quadratic going on. That's okay. Notice when we got down to this line here, 3x squared minus 15x minus 18 equals 0. There's a common factor. Always be on the lookout for greatest common factor, which is 3. So I factored out the 3 and then divided both sides by 3. Observe that 0 divided by 3 is just 0. So now we have a much more compact expression, quadratic, which, we have, I think this would be solvable by the AC method if you chose to. It would certainly be solvable by completing the square or using the quadratic formula. And in this case, I just used the quadratic formula. So that's negative b plus or minus b squared minus 4ac divided by 2a. Identified what a, b, and c was, plug it in, and just chug through the details. And now we have x equals 6 and x equals negative 1 as possible solutions. We're going to need to check these. So that's page 2 coming up. Okay. There we go. So page 2, putting in 6 for x, and putting a question mark over the equal sign to see does, in fact, the left side equal the right side. It does, so this is great. Negative 1 for x, putting it into the original equation, going down, and sure enough, right side equals left side, so we're good. So both solutions worked. Takes care of the second example. And we just have one more. So here we are right here. Let's see. So number 3. So 1 divided by 5x plus 10 minus 3 times x squared minus 4 divided by, equals 4 divided by x minus 2. Now, we have some factoring to do in terms of the denominators. Here, 5x plus 10 is subject to greatest common factor principle. X squared minus 4 is a difference of squares. Therefore, it equals x plus 2 times x minus 2. Now we can look at this and analyze what's the common multiple of all these denominators. Well, we have a 5, we have an x plus 2, an x minus 2, and then the product x plus 2 times x minus 2. Putting that all together, the common multiple, and I think the least common multiple, in fact, would be 5 times x plus 2 times x minus 2. So in green, I'm multiplying both sides of the equation by that common multiple. Next step is to distribute, cancel out where you can, basically. And so I've indicated that with red strike-through marks for those factors that can be canceled out. Next line now, we don't have any denominators left over, so this is good progress. Basically solve for x, do whatever it takes. And in this example, probably the most complicated thing, frankly, was that 57 is actually a multiple of 19. Not entirely obvious, but 3 times 19 is 57. So good. Now checking this work, let's see, we have only one answer to check, negative 3. And so I'm putting that in place of x, right and left side with an equal sign over the equation, because I don't know if left actually equals right side. That's why I'm testing this. But after some arithmetic, sure enough, it comes out that left side equals right side. So this is great. Yeah, I think it seems to me these are the most complicated types of problems in 3.4. But we still have another type of problem, a different type altogether, which is radicals. So that will be the last video. Thanks a lot.